Hello Driving Intelligence community. Just as a recap, the reason for this video is because I'm doing a transmission rebuild for my 10th Gen F150, the 4R70W rebuild that turned out to actually only be the 2.3 accumulator that caused me to lose third gear. Anyway, I wanted to show you how I replaced the rear main seal. This rear main seal activity actually applies to several different engines from the Triton family. I think the 6.2 liter V8, the 4.6 liter V8, and I think it even is a close match to the Coyote 5 liter engine. So part of the video at the end, the lighting is not so good, but you can still see what's going on. But I thought I'd share with you what I did on my 10th Gen F150 to replace this rear main seal. Everything I've talked about, the parts, the videos that I've referenced before, they're all going to be linked in the description, so check those out. So let's get started on this rear main seal. Since the transmission's pulled, I decided to go ahead and replace the rear main seal. The easiest way I found to do this was to put a bolt, a transmission mounting bolt in, and use a screwdriver, and I was able to loosen up those nuts holding on the flex plate very, very easily. What I'm also going to do is mark these locations just to make sure it goes on the way it came off. I don't know that it makes a difference, but for me, I'm going to make sure it goes exactly back the way it was. Quick clarification after that first segment. The flex plate can only go on one way. The bolts are machined into the crank so that it only goes on in one orientation, so you don't have to mark anything to put it back on. Flex plate has been removed, and you can see upon initial inspection that there's no oil on the seal itself. I'm going to replace it anyway, but you can see some oil coming up from what looks like probably the oil pan gasket, or that component, this whole component here that holds the seal in. So we're going to take this off, we're going to clean up this entire surface, make sure everything's torqued properly, and get it back together with the new seal. The cover plate on the rear main seal is removed, and you can see the old seal, which actually was extremely loose on the crank. It was a good idea, I think, to go ahead and replace this. I'm going to replace it with the FEL-Pro PTFE. What also came off was the oil slinger that they say needs to be returned back on, so I'm going to keep that, make sure it's okay. And for those of you who ever wanted to see what the back of a 5.4 looks like, there you can see the crank cap and the bolts. There's the crank shaft. And they actually made this pretty easy to do if you get the transmission out. Once the transmission's out, you have a lot of options here. As a side note, I've been reviewing Valvoline Restore and Protect shown in my other videos and feel this is a unique opportunity to see the inside of the engine where the rear of the crank is exposed. Above the crank, there is carbon buildup, but below the crank, notice clean metal. I confirmed with some engine builders that this is normal. Fresh oil does not flow above the crank, allowing the detergents to remove the carbon. However, notice that the oil flowing down from the crank has thoroughly cleaned the surfaces the oil comes in contact with. I can't say the cleanliness in this area is due to the Valvoline product, as I have been regularly changing the oil using other quality synthetic products since I bought this truck with 165,000 miles on the clock. Everything's cleaned up. You can see this is nice and shiny now. I used a plastic razor blade and also some isopropyl alcohol to get all the residue off. I use isopropyl alcohol on the crank as well. And here you can see the gasket that goes all the way around the block. And the cover that goes here actually is pulled into that gasket. I also made sure to clean up the cover. This is spotless now. It was full of crud. That will help allow the oil to move around in there, keep everything clean since I'm using high quality oils now. And to make sure that that stays sealed on there, I'm using some Permatex Ultra Black. And here is the PTFE seal I'm going to use. It comes with a tool. I'll link all this stuff in the description of this video. But apparently this is one of the best you can use. And you have to install it on a dry crank. You can't use any lubricant. That's why I've cleaned this with isopropyl alcohol. One of the critical parts now is to make sure that I do put RTV sealant in all the right places. It's very obvious to put it around the flat surface here where the cover is going to meet. But what I want to do is also make sure that where that crack is right there, where the block meets the valve cover gasket, I'm going to put a bead right in there against that crack on both sides before I put the cover on. So let's go ahead and apply some RTV and get the cover started. RTV has been applied as a thick bead, and I've also applied the RTV up here where the block meets the oil pan, and now to set the cover. The RTV sealant says to put the bolts in finger tight until you see the bead squeezing out, which is what you see here, and to let it sit for an hour before we're torquing it to proper specification. To attach the rear main seal cover, there is a pretty specific torque specification, and I followed this spec to the letter. First, torque the 6 plate bolts to 89 inch-pounds in this order: left middle, right middle, left bottom, right top, right bottom, and left top. I went around twice to be sure the bolts were properly torqued. Moving on to the oil pan bolts, the torque spec is 15 foot-pounds starting with the bottom right and then the bottom left. After achieving the torque spec, tighten each bolt another 60 degrees and let set for 24 hours before driving, allowing the RTV sealant time to cure. Apologies for the poor lighting. As I mentioned already, the FEL-Pro PTFE gasket must be applied to a dry, grease-free crank. Otherwise, the seal will likely fail. The seal I use comes with an installation tool, making install a breeze. I've got the seal in, and I use the old seal with a hammer to tap it in. Now, I searched for a spec that talked about how far this seal should be pushed in. I saw something on a forum. It wasn't actually a spec, but somebody referenced a spec that said it should be in 3/16 of an inch from this outer edge here. What I used is one of these dial calipers, and you can see that it's got a little pin on the end, and I measured it, and I'm not getting the 3/16 of an inch, and I really don't want to push it in further for fear of doing something that shouldn't be done. Now, they call this an oil slinger, but really it's just a seal. And you can see it looks like it should go on this way, but actually it goes on this way with the lip facing toward the outside. What I did was I measured the thickness here, and it's definitely within the size of this depth is definitely within the size of the slinger. So now I'm just going to push the slinger in to make sure that it's flush with this outer surface, and we'll be good to go. Sorry for the shadows. And there we go. So now it's beyond the surface where the flex plate is going to be mounted, and I can go ahead and get the mounting plate on there. Now, far be it for me to do anything that doesn't get a little bling. This plate here I've cleaned up, made sure that all the surface rust was removed, and I put a coat of Rust-Oleum paint on here just to make sure that there was no corrosion. But before I put it on, I'm going to clean up all these surfaces with a razor blade to make sure they're nice and smooth, and that I don't have anything pushing this plate out, preventing proper alignment of the transmission against the block. Once again, very sorry for the poor light quality. Placing the light behind me while I'm working in the transmission tunnel causes a lot of shadows, but you should be able to see what I'm doing. Of course, the last step after putting a new rear main seal in this engine is to put the flex plate back on. And these bolts are torqued in a 3-tiered step, starting with 20 foot-pounds, and you do it in a star pattern, just like you do lugs on a wheel or on a tire. 20 foot-pounds first, 40 foot-pounds second, 60 foot-pounds third. And to make sure that the flex plate and engine don't turn while you're torquing it up, I put a box wrench up here. I took one of the bolts off of the case, the transmission case that holds it to the block. I got that tooth locked in here. No worries about any kind of torque breaking off a tooth. That held it stable, and it's real easy to get back off. And that's it. I hope this helped you out. And if you did, don't forget that thumbs up. Always check for my links in the description of this video, and I'll see you next time on Driving Intelligence.